They promised a coding revolution. AI tools like GitHub Copilot and ChatGPT were touted to write 80% of your code, multiplying developer output by 10x. One viral story even claimed a solo founder shipped a complex SaaS app in just 2 days using AI, generating an alleged $30,000 in its first month. I decided to put these audacious claims to the ultimate test, replacing 50% of my code in a real-world project for an entire month. The results, they shocked me to my core. Why should you care? Because the average developer spends 28% of their week just fixing bad code, not creating new features. If AI could truly cut that time in half, or even just assist in the mundane, it would redefine our jobs, boost careers, and unlock unprecedented innovation. But what if the promise is a trap? What if chasing AI efficiency leads to a deeper, more insidious problem? The stakes for your career and the future of software couldn't be higher. The fear is palpable. Be an early adopter and ride the wave, or be left behind as AI-native developers outpace you. But here's the often unspoken anxiety. What if AI succeeds too well? What if it fundamentally cheapens the craft, turning us into mere prompt engineers overseeing code we barely understand? I entered this experiment with optimism, but also a healthy dose of skepticism, ready to confront whatever truth emerged. My personal reputation and the integrity of a real client project were on the line. My methodology was rigorous. I picked a moderately complex web application project, defined 50% AI code by lines of executable code and tested function blocks, and committed to using GitHub Copilot and ChatGPT for any new feature or refactor. The rules were simple: AI first, human override only if absolutely necessary for correctness or performance. I tracked every minute, every line, every bug. This wasn't a toy project. It was a live, production-bound application for a real client. The first week was pure euphoria. Boilerplate code that typically takes hours vanished in minutes. Setting up basic API routes, generating database schemas, even writing initial unit tests, Copilot was a tireless, lightning-fast assistant. I felt like a coding god, pushing out features at a pace I hadn't seen since my early days of unchecked caffeine consumption. My productivity metrics initially skyrocketed, suggesting a potential 3x speed increase. This was the dream, right? Consider this example: implementing a user authentication flow. Manually, it's hours of writing routes, hashing passwords, handling sessions. With AI, Copilot suggested complete express, JS routes, JWT token generation, and even basic error handling within seconds. ChatGPT drafted the MongoDB schema and even suggested robust validation rules. I barely typed anything beyond function names and prompts. It felt like I was merely assembling prefabricated, perfect components. Then the cracks started to show. As the project's complexity grew, especially with domain-specific logic and intricate business rules, AI's performance plummeted. It excelled at generic, well-documented patterns, but stumbled badly on novel problems. I'd feed it a detailed prompt for a custom data aggregation algorithm, only for it to return a generic sorting function, or worse, something completely off-topic. The initial excitement began to fray. Here's the part nobody talks about: the hidden cost of debugging AI-generated code. It's often subtle, logically sound, but contextually wrong. Imagine an AI writing a function that perfectly sorts numbers, but the business rule required sorting strings alphabetically. The code works, but it's fundamentally incorrect for the task. I found myself spending 60–70% of my time not writing new code, but critically reviewing, testing, and often rewriting AI's flawed suggestions. My productivity was a mirage. According to Dr. Sarah Jansen, a leading AI ethics researcher at MIT, current generative AI models are pattern matchers, not true innovators. They excel at recombination and interpolation of existing data, but struggle with genuine novelty or abstract reasoning that requires deep domain understanding. This directly mirrored my experience. The more unique the problem, the more I became an editor and less a creator, constantly course-correcting AI's best guesses. My role profoundly shifted. Instead of solving coding problems, I was solving AI prompting problems. The art became about crafting increasingly precise, almost surgical prompts to steer the AI away from generic solutions. It was less about algorithm design and more about being a linguistic engineer, constantly trying to bridge the gap between human intent and machine understanding. This was an entirely new cognitive load, often more frustrating than writing the code myself. Beyond correctness, there was the issue of performance. AI-generated code, while functional, was often not optimized. It might use inefficient loops, redundant database calls, or suboptimal data structures. When I benchmarked a critical feature's AI-generated implementation against a manually optimized version, the human-written code ran 3x faster, consuming 40% less memory. Good enough isn't always good, especially in production systems. Here's the twist that nobody tells you. The 50% AI code metric was a deceptive illusion. While AI might have generated half the lines of code, it contributed to less than 15% of the truly critical unique business logic . The vast majority of AI's output was boilerplate, utility functions, or highly generic implementations. My core intellectual effort remained focused on the complex, nuanced parts that AI simply couldn't grasp. The 50% was almost entirely low-value busywork. This leads to what I'm calling AI debt. Just as technical debt accrues from hasty human code, AI-generated code introduces a new form of reliance. It's often harder to refactor, reason about, or even fully trust because the underlying decision-making process is opaque. You lose the intimate understanding of every line, creating a black box within your code base. Future changes become more brittle, more prone to unintended consequences, and ultimately more expensive. The biggest shift was internal. My muscle memory for writing certain kinds of code atrophied. I became faster at prompting, at critiquing, at integrating, but I felt a distance from the raw craft. Is this the future? A shift from artisan to architect, where your primary skill is not building but discerning and guiding? The answer is complex, forcing us to reevaluate what coding truly means in an AI-powered world. After 30 days, the project was indeed shipped. It was functional, met all requirements, and launched successfully. But the journey was far from the frictionless AI utopia I'd been sold. The final codebase had its quirks, a few lingering inefficiencies, and a certain AI flavor in its structure that made some parts feel less personal, less deliberate. The project was done, but at what unseen cost to my skills and the code's long-term maintainability? So what's the verdict? AI didn't replace 50% of my coding work, it transformed it. AI is an incredibly powerful assistant for mundane, repetitive tasks and boilerplate generation. It frees you from the drudgery, allowing for faster initial drafts. But it absolutely failed to replace the core intellectual challenge, the creative problem-solving, and the deep understanding required for complex, novel, or performance-critical features. It's a magnifying glass, not a clone machine. Here are your actionable takeaways. First, embrace AI for boilerplate, testing, and documentation. Second, master prompt engineering. Your ability to articulate complex problems precisely is now paramount. Third, never outsource critical thinking. AI output must be rigorously reviewed and tested. Fourth, focus on architecture and system design. These are the human-centric skills AI struggles with most. Your role isn't obsolete. It's evolving to a higher level of abstraction. This experiment was just one small window into a rapidly changing landscape. The future of coding isn't about humans versus AI, but human-AI collaboration. The developers who thrive won't be those who ignore AI, nor those who blindly trust it, but those who learn to wield it as a precision instrument, understanding both its immense power and its critical limitations. This journey forced me to confront my biases, adapt my workflow, and redefine what it means to be a developer. The true cost of replacing half my code with AI wasn't measured in lines, but in vigilance, critical review, and the constant mental overhead of being an AI's editor. It saves time, yes, but at the expense of absolute creative control and intimate code understanding. The question isn't can AI replace us, but at what hidden price does efficiency come? Think about that for your next project. What will you do with AI?